Let us now welcome two commentators who will jointly respond to the presentation of Spring 8 and SACLA. The first remarks will be given by Dr. Caterina Biscari, Director of Alba Synchrotron in Spain, immediately followed by Professor Andrew Harrison, CEO of Diamond Light Source in the UK. Professor Harrison is one of the RIKEN alumni in Europe as well, as was mentioned by our President in his welcome remarks. So, Dr. Biscari, Professor Harrison, your remarks, please.
Thank you. I will start, and I want to thank the organization of this symposium for giving us the possibility and the opportunity to speak to such a wide audience. And I want to take as my first sentence, the last sentence that I saw in the previous report, that synchrotron light is something that should make all of us happy. And I will, next please, I will talk mainly of LIPS, but let me just give a few information about the facility of which I am the director, which is the Alba Facility in Spain. It's a facility which is one of the youngest. It's in operation since 1 decade, and is still in the development moment of adding new beam lines. We have in this moment 10 beam lines, and we are building 4 more beam lines. We have had almost more than 2,000 experiments carried out during this time, and 50% of them are dedicated to life science, 50% dedicated to material science. We have more than 6,000 users. Let me just mention that when Alba started 10 years ago, there were only 600 people using synchrotron radiation in Spain. Now we have more than 6,000 users. Among them, there are some Japanese, not many, but there are few Japanese groups who also come here. Even the Toyota, which was mentioned in the previous slide. So, and we are planning, as Spring 8 also, we are planning the upgrade to the 4th generation. Next, as is done by many other facilities. Few years ago, we started inside Europe to talk, to check the possibility of better collaboration among the facilities dedicated to synchrotron radiation and to free electron lasers. This was the LIPS startup, was 4 or 5 years ago. LIPS stands for League of European Accelerator-Based Photon Sources. And now it was a dream a few years ago, and now it's a reality. We are almost 20 facilities. Some of them were already mentioned also in the previous presentation. There are 2 facilities with high energy ACRF and Petra 3, and there are several synchrotrons in the mid-range energy, among which is Alba. But altogether, we are operating more than 300 stations, which means that we are offering more than 1 million of hours per beam time per year to a huge community of more than 35,000 users, most of them from Europe, but also, of course, outside Europe. We have IFEL, we have the European IFEL on the high energy part, the Swiss FEL and the Fermi on the low energy. So it's a real great community and a real asset for the European research area. Next. And almost all the facilities are based on national funding, but we are international. Next, please. And our vision is to be a catalyst for solving global challenges. We heard in the previous presentation what synchrotron radiation and FELS are useful for, and is no need to repeat that. But the important thing is also not only to work as countries, but to work together with the others. And of course, for us, the others, the nearest are Europe. And so we want to integrate and also to be science for peace in this moment more than ever. And we want to use the power of our combined voice in order to ensure that Europe is also maintaining its leadership. Let me remind you that the first fourth-generation synchrotron in operation was built in Europe, MAX 4 in Sweden. The first third-generation synchrotron moving to fourth generation is also European. It was mentioned before, ESRF. So we are really going forward and we want to maintain this momentum. Next. We are providing solutions to all societal challenges, as already mentioned before. Just one, of course, which is very present in our life in this moment is the COVID-19, and we have been part of the solution for this problem that the humanity is facing. And of course, we were part of the solution because we were ready to give, as I saw in your slide before, the solution provider, and this was one of the solutions. Next. And not only for the public research, the academy, but for the industrial research. And also here it's very important that we work together inside Europe to develop a closer link with the industrial world, which is using all our facilities, but there are several programs now also funded and foreseen from the European Commission in order to have what we call the open innovation. Here is one example, is the example of batteries. Another of the problems of the challenges for the future of the humanities is to have to provide energy storage in the most powerful and sustainable way. So it's the example of research to putting together consortium of research infrastructure, not only photons, but also others, what is inside area and industry. Next. And another important point, of course, is the management of the data. As we all know, that the amount of data which is being produced is growing exponentially. So what we need to optimize all our tools for dealing with the data, their analysis, their online analysis, and also here we need to work together. And this is what we are already doing through dedicated programs funded by the European Commission, and we are foreseen to do that later on, even more. Next. And we are contributing to the ERA, the European Research Area, with participation in several programs from the European Commission in the Future Horizon Europe programs as LEAPS or as LEAPS plus other network of other analytical facilities, or as LEAPS plus area network plus industry. An example is a recently approved project on the circular economy. Next. So we have learned from the last period, from the challenges of the last period, to develop and to find opportunities for a brighter future. Next, and to go for a greater digitalization and automatization. What we are doing now in this moment is to prepare what we call ESAPS 2022, is the European strategy for the accelerator-based photon sources, where we want to focus on which are the key collaborations and the key projects where we want to work together and to find solutions to the grand challenge. We are, for example, aiming at providing what we call targeted challenge-driven access through contribution from all the meantime, from all the facilities to specific challenge. And of course, we work together also in the technology roadmap. Many of the synchrotrons of third generation are now planning or doing already the upgrade to the 4th generation, and this is developing together the technologies will be much more effective. And we want also to focus on the societal impact of LIPS. Next. And with this, I end, and I hand now the micro to Andrew.
Thank you very much, Caterina, and thank you everyone for giving us this opportunity to connect with, well, former colleagues from RIKEN. I recall spending many months to 20 years ago, first of all with Katsumata Sensei at the Wachi campus, and when he moved to when he moved to Spring 8, joining him there as well. So it was also a real pleasure to see the progress that Ishikawa Sensei presented to us, and also the plans for the future. I just want to add really one more point from the European perspective to what Caterina has said, and that's to draw on the wider aspects of how facilities such as synchrotrons can connect to other kinds of ways of measuring materials and getting insights into living systems. And that's the role of synchrotrons also on campuses. So we've heard already about the impact that synchrotrons have had on COVID-19, playing a critical role to understand the structure of the virus and its variants. But increasingly, life scientists are trying to gain deeper insights into these complex systems by bringing together a variety of techniques. So, for example, over the last 2 years at Rutherford and other centers for facilities, stronger insights have been provided by bringing together synchrotron radiation with X-ray microscopy techniques and laser microscopy techniques, also co-located with the ability to culture the virus and infected cells. So here is an example recently published in Nature of bringing all these techniques together to actually look at the infection mechanism in living cells. And in the physical sciences too, we're increasingly seeing that scientists are bringing together a combination of techniques to gain deeper insights into the structure of materials. Here, an example bringing together synchrotron X-rays and also neutron measurements at the Rutherford lab using the ICIS facility, also in combination with artificial intelligence methods to accelerate material discovery here in the context of developing new materials for lithium-based batteries. So what we have seen in the last 5 to 10 years is an increasing co-location of facilities. And I'll give you one example here from Diamond, but it's starting to be propagated much more widely. Here, the co-location of a national center for cryo-EM alongside the synchrotron. And this brings together not just the complementarity of measurements, cryo-EM and synchrotron X-rays, providing different ways of looking at the structure of materials, but also the economy of scale of technical support and training opportunities here, and building up an interlinked community of scientists and technicians. And that's part of a wider phenomenon. Again, I'll illustrate that with what's happening at Harwell, at the Rutherford lab, but is increasingly being stretched out across Europe. So here, of course, we have the synchrotron, Diamond, but it's surrounded by a variety of other facilities. We have the ICIS facility, and Philip King spoke earlier also of the RIKEN Muon facility here. We have the central laser facility, which was used in those measurements from 2 slides ago in the infection pathway in COVID-19, the co-location of a cryo-EM, and a facility for medical research with genetically engineered mice. Again, there are increasing connections there with these facilities for neutrons and X-rays. In addition, if I can just go on to the next slide, I appear to have hung for the moment. It's not advancing. Sorry about this. Oh, there we go. Sorry, I've skipped on 2 now. Also, the co-location of support laboratories. So visiting scientists from universities or industry wish to set up complex measurements. It's necessary often to provide them with complementary laboratories to do those preparatory measurements, and also to give them office space so that they can co-locate for extended periods of time. So we have universities that will spend months, in some cases several years, sending research groups down to work alongside the facilities. And then most recently, the establishment of government-funded labs to provide challenge-focused institutes. So in the top left, the recently opened Rosalind Franklin Institute, which develops enabling technology for biomedical research to enhance both cryo-EM and synchrotron methods. And in the bottom right, the Centre for Battery Research in the UK, which was located at the Rutherford in anticipation that co-location of traditional laboratory equipment with these larger facilities will lead to synergies of between scientists and also into technical development. So not surprisingly, these developments also increasingly attract the interest of industry. And over the last 10 years or so, at this and other campuses across Europe, we're seeing increasing inward investment in companies who wish to co-locate, where you've got this focus now of large facilities, support laboratories, and increasing numbers of people from universities, so that the synergies between these different agents are maximized. So finally, I've illustrated this phenomenon of campus development with the example of the Rutherford lab at Harwell, but we see the same happening in Grenoble in France, where there's a co-location of ESRF and the ILL, in PSI in Switzerland, again, photon and neutron facilities, and soon to be completed, the combination of the European neutron facility, ESS, in London, Sweden, co-located with MAX4. So although it's not absolutely critical to co-locate, and we can also network people from separated sites, there are certain advantages in the geographic proximity of these facilities, allowing really powerful research campuses to develop, as we see at Wakoshi in a different context with RIKEN's a combination of research facilities and also world-class researchers. Thank you.
Thank you very much for valuable inputs, Dr. Biscari, for the young, dynamic Alba Synchrotron, and Professor Harrison from a well-established and still evolving diamond light source.